Let's take a look at 6.6. Let's go back and touch on things that we need to touch on. So 6.6 is what you guys did the day that I was out.
Oh, that thing.
Oh, that thing, yes. Degrees and radians and angular speed and...
I did a whole
Huh? I can't even see the sheet of paper you're holding me, let alone. Yeah, we're going to talk about all that. See, it doesn't have respect for what I've done, you know, all that work.
It could be in here.
Are we doing 660 and 670 today, or just 660?
Well, I don't know, we'll see how it goes. By the end of class, we'll have the week planned out. Okay?
Hold on.
All right, so step one in all of this
Is having the paper.
is degrees to radians, radians to degrees. Okay? And I gave you a chart, correct?
Yeah.
Gave you a
Sure.
chart, and I said, you've got to know this chart. This is not quite the level of the chart, but it is stuff that we need to know. And the reason is because we're going to get a problem at some point where you're going to be asked, what's the cosine of pi over 3? And what can't happen, let's see, what did I say, pi over 3? So radians to degrees, you would multiply by 180 over pi. Okay? So we can't go, okay, pi over 3, let's see, pi over 3 times 180 over pi, pi's cancel, and 180 divided by 3 is 60. So 60. Why can't we do that? A, it takes too long, and B, it's not the answer. But you're spending so much time worrying about what it is that you lose track of what it is that you're supposed to be doing. Okay? The question there was, what's the cosine of pi over 3? And so the main part of the question can't be, oh, what's pi over 3 in degrees? And so that's why that chart becomes important, because you got to know what pi over 3 is. Now, I don't know if we did in here or not, but there are some little tricks. So if we are talking about just pi over 3, okay, what is pi over 3 in degrees? 60 degrees. Okay, and the little trick here, for me anyway, is that the denominator times the degree measure will always equal 180 degrees. Which therefore means that 90 degrees is equal to pi over 2. And even if it's angles that we aren't really familiar with, if we think of it that way, it might help. Like for instance, if we said, what's 18 degrees? And because it's 180, it becomes a pretty simple answer. So I would so much rather do that than try to go through this whole thing. Or if we're going from degrees to radians, what would we do? Multiply by pi over 180. Okay. I'm going to use these when it's something bizarre, like 32 degrees. I don't know 32 degrees, so I'll put it into that. But if there's any way that I can just do the 180 thing, that's going to make life a whole heck of a lot easier, right? Now there's one that you are going to want to know that's going to come up a lot, and that's 45 degrees. And 45 degrees is pi over 4. Now, up until now, you probably didn't think too much about the fact that that 4 times 45 is 180. You will get better and better at that, okay, as time goes on. Thank you. You will get used to that. If you want to rationalize it in your head, if you want to logic it out, what's one whole revolution in radians? 2 pi, right? 1 revolution is 2 pi, which means that half a revolution is pi. So pi is 180 degrees, which, oh, by the way, is why this works. Because if 180 degrees is pi, then what are we actually multiplying by here? We're multiplying by 1. Because we're multiplying by the same thing over itself, and that's why we're allowed to do that. So anyway, if 180 degrees is pi, then 90 degrees becomes pi over 2, half pi or pi over 2. And if 90 degrees is pi over 2, then 45 degrees is half of that, which would be pi over 4. So you can go through it that way, but you will know pretty shortly, and it'll be a given, what's pi over 3? 60 degrees. What's pi over 4?